واحلل عقدة من لساننا يفقهوا أقوالنا والحمد لله رب العالمين.
Alright, thank you, Arham for the doa. Okay, just to remind you again, today we have test. Okay, during remedial class. Have you prepared for the test? I think also Alan, so as S20 brilliant, have no problem to score the paper, I guess. And without further ado, let's continue our class. So basically today, my objective, I just want to cover, I want to repeat again the emission spectrum, to be specific hydrogen emission spectrum, right? And I'm going to continue with ionization energy as well. Okay, so that is our objective for learning. Let me share you the slide. Can you see my slide? Participant can now see your application. Okay, so hopefully you all boleh semua boleh nampak lah.
Nampak, sir.
Right. This is electromagnetic spectrum. Remember, as a human being, kita ada limitation kita. We cannot see all the wavelength. Our eyes only detect the visible wavelength. So visible wavelength ni sangatlah kecil kan. So it's this area. So from red to violet. So itu yang range kita nampak. But the electron, remember the electron tu dia can absorb the energy from radio until gamma. So that is nature of electron. So ini yang just to repeat again. What is the difference between the continuous emission and absorption spectrum? This is old slide. And so my wife share the slide with me. So saya ambil dia punya je, credit to her. Sebab I'm the person yang tak pandai buat slideshow. To be honest, I'm not the one yang pandai buat slideshow, and I'm the one yang tak pandai nak buat nota actually. So in the class, basically saya akan jot down dekat depan. So yang penting sekali adalah emission spectrum. So itu yang akan ditanya dalam exam. But the idea asks us to tell the student that we have two type of spectrum, continuous spectrum. Bersambung, spektrum yang bersambung, tak ada pecahan. There is no separation between the wavelength, between the energy. And we also have line spectrum. So line spectrum tu ada dua, emission and absorption spectrum. Hopefully you still remember the difference between this emission and absorption. So emission is when electron fall from higher energy level to the lower energy level. So absorption is when electron absorb energy and get excited. Alright. What is the meaning of hot dilute gas, prism, osmosis? This is how they produce the emission spectrum lah. So not really important lah. Yang itu research tunjuk ni. So how they produce the emission spectrum of hydrogen. So dalam bulb ni ada hydrogen. So energy then split by using prism tu. Ni pun dah explain tu hari. So ini yang berlaku lah. Right. So electron in higher energy level ataupun higher energy orbit, and then they fall to the lower energy level. So dia akan emit the line ataupun emit the energy. So each line represent specific energy. Benda yang sama je, kita dah nak habis lah. And kenapa the spectrum knowledge is important because all elements in the world, in the universe, will have different pattern of the electron. Different pattern of the emission spectrum, because all of them have different arrangement of electron. So we use this in astronomy, for example, kan, Okay, this is a hydrogen emission spectrum. If you see this, what we call this picture, N1, N2, N3, N4, N5, N6, and 7. This is indicate energy level in atom. So electron, let's say electron at first energy level ni, so dia boleh travel from N1 to N2 ataupun dia boleh pergi to N7. Kenapa? Like I said again, electron can absorb the energy. If you give them energy, so dia akan absorb and then dia akan get excited. Of course, there is no N0. There is no N0 kan. So the paling minimum energy level adalah N1. So this is N1. Right? At the first, when you give that electron tu dia akan excited. To what extent dia akan excited, I'm not sure lah. It depends on energy that you give to them. Let's say I give the energy, very high energy, so electron tu excited kat N7. So this is electron tu dia akan jump to the N7. But bila sampai ke atas, electron tu gayat. So dia tak akan forever stay in N7. So dia akan fall back to the ground state. So dia akan jatuh. To what energy level electron fall, it depends on electron itself. So kalau dia jatuh to the N1, so dia akan produce Lyman series. And the energy release ataupun the energy let go is equal to the UV energy. Can we see that? The answer is no. But teacher, how they know this is a series? Because they use a UV lamp. Itu dia jawapan dia. That is why, kalau awak tengok dekat Balmer series ni, this is under visible light. So this is under visible light. Dia ada color kan, merah, hijau sampailah purple tu. It is because we can see this Balmer series. Macam mana Balmer series? Lebih kurang macam ni lah. You can see spectrum macam ni. But the rest, Lyman, Bastian, bracket, P5 and so on tu, we cannot see them. But the most important is, you know, the energy tu equal to what wavelength. So for Lyman is equal to UV. Bastian, bracket, P5 ni is equal to infrared. Kenapa sampai 3? So we have P5 here. Kenapa dia sampai 3 IR? Yes, because IR tu terbahagi pada 3. We have far IR, near IR, mid IR. So ada jauh, dekat, tengah-tengah. So that is why kita ada 3 type of IR. So ini sahaja yang korang perlu tahu pasal hydrogen emission spectrum. Sangat-sangat simple IB ni, kan? Do you need to calculate the energy level ataupun the energy represent the wavelength tu? Yes, by using E equal to simple equation. This is Planck constant and frequency and also speed of light. So that one is later kita akan tengok. Inilah dia energy level dia. Lyman. So this is wavelength dia. You can see the shorter wavelength, the higher frequency. Sebab apa? Sebab dia travel jauh. Kenapa ada banyak line ni? Like I said, if you give the electron the energy in form of photon ke ataupun whatever form of energy, electron tu dia akan excited. Kalau electron tu excited to the N2, N2 akan jatuh to N1, produce Lyman. If the electron excited to N3, still Lyman. N7, still Lyman. Tak kisah origin dari mana, as long as dia fall, and then dia fall to the N1, dia akan produce Lyman series. Tapi macam saya cakap dulu, if you give them 10 energy level, let's say 10, dia akan excited to the 7. Kalau dia fall to the N1, dia akan release 10 jugalah. Tapi kalau dia fall to the N2, dia akan release maybe 8. Ada lagi 2 kat situ. But still, dikira sebagai this is excited state, and then they fall back to the ground state. Lower from excited state always refer to the ground state. So this is bracket, this is P1. So sama je lah. Ni yang berlaku dalam hydrogen atom. Hydrogen emission spectrum. So jangan kita tahu when you want to write the electronic configuration for hydrogen is 1s1, betul tak? Betul tak? Tak betul. Ada new theory. Orang dapat Nobel Prize ke? No, right. This is our guideline. Whatever that you write the electronic configuration, yang sehani saja tu dulu, is all electronic configuration dalam ground state. 1s2, 2s2, 2p6 dah semua tu kan, yang panjang-panjang tu, all of them in the ground state, dalam keadaan yang paling stable. Tapi atom itself is not stable, bukanlah not stable. I mean the electron inside the atom is not static, dia keep moving. So dia boleh gerak lah suka hati dia. Kalau you give them the very high energy, then the electron tu dia akan bye-bye the atom lah. Itu adalah ionization energy yang kita akan cover later. Okay, ada masalah so far pasal hydrogen atom? Ada, terlampau senang, betul. So, if you use your observation ataupun if you look at this, what we call this, picture ataupun figure ni, what we can see, right? You can see, let's say if you got from, if the electron at E7, N7, fall to the first energy level, can you see how much energy yang dia release? Banyak ke sikit? 62.6 je. Banyak ke sikit? Energy yang dia release.
Sikit compare dengan lain.
Sikit compare dengan lain. Okay. Kalau this is N7 kan, kalau you look at the N2, electron fall to the first energy level, so dia akan release this wavelength 12157. So a bit longer, and then 9262 a bit shorter. So you can see that in terms of the energy, ini lagi banyak energy dia release kan, sebab impact. Macam kita jatuh tangga, kita jatuh tangga satu step tak ada apa, betul tak? Kalau kita jatuh katil double decker tu agak sakit lah kan. Kalau korang nak test, korang, if you jump from the higher energy level ataupun higher level, so korang akan lagi sakit lah impact dia tu. So shorter wavelength 92.62, meaning that the frequency dia tu tinggi, so means the energy is higher. That is why this is under UV. This is under visible light. 3889 ni is a violet, and then this is must be something yang red kan. So semakin tinggi, this is IR, because of, if you compare the wavelength, so you can get the answer. So you have to look it carefully, and then Try to figure out benda tu lah. Okay.
Yang wavelength tadi saya tunjuk tu kan. Maksudnya nanti kena compare dekat wavelength yang dia kasih kat data booklet tu lah.
Dalam data booklet dia kasih wavelength. Dia nanti rasanya dia akan minta kira lah. Dia akan minta kira E equal to HV tu tadi, Planck constant, then you explain jadi frekuensi dengan apa speed of light kan. So it's a very simple calculation, and if you refer to the A-level textbook, memang akan ada specific calculation sebenarnya energy. So macam dia bagi kat awak kat sini, dia bagi wavelength kan. So dia suruh awak kira the energy from one to one, no, not like a Rybert equation ke apa, itu tak perlu tahu. Tapi it's very simple equation yang ini sahaja. So you just substitute je lah yang itu. Okay, nature of atom itself converge at higher energy level. So inilah yang kita boleh tengok tapi not so detail. Perlu tahu pun. Just nak bagi tahu dia converge dekat higher energy level sahaja. Okay, next is ionization energy. What does it mean by ionization? If you give the electron very high energy, electron akan get out from the atom. Dia akan bye-bye the atom. And when this happen, the atom is said to be ionized. And the definition for the ionization energy is a minimum energy required, okay, to remove. Ini kena tulis sikit lah kot. So when we want to define, when you want to define the energy level, ionization energy, you kena guna saya besarkan huruf tu, to remove one electron from gaseous ini definition dia, to remove one electron from one gaseous atom and form ion. Ini adalah definition for first ionization energy. Kalau second ionization energy, definition dia adalah again minimum energy required to remove the second electron pun awak boleh cakap kan. Pun awak boleh define as a remove the one electron from gaseous ion positive one pun boleh. So it's the same meaning. Sebenarnya kalau dalam IB ni dia hanya emphasize kan first ionization energy sahaja. So the thing is yang ini to remove one electron from one gaseous atom and form ion. Kalau second ionization energy is a minimum energy required to remove one electron from gaseous ion from benda yang sama, boleh diterima juga. So dia ada macam-macam definition boleh buat. Ataupun kalau awak tak suka macam tu, mungkin awak boleh cakap energy required to remove the second electron from positive one gaseous ion. That is a second ionization energy. The third ionization energy, benda yang sama juga. Energy required to remove the the electron from the second gaseous ion. So that is the definition. Apa sebenarnya ionization energy ni? Ni definition dia. The minimum energy required to remove the electron. Ada definition dia macam ni tau, dalam sistem pemarkahan IB kan, you have to be specific to remove one electron from one gaseous atom. Kadang-kadang ada student je define macam ni. So ionization energy to remove one mole from a gaseous atom and form gaseous ion. Ataupun dia akan cakap ya, ada 3 definition. Mana satu yang korang rasa terbaik? Yang mana satu korang rasa boleh dapat markah? And then the general equation for the energy adalah M G ini korang kena alert lah. Kena nak buat macam ni lah. So dia adalah ion plus electron. Itu barulah balance. Okay, look at these 3 definition. What do you think? Yang mana rasa suit dengan korang punya pemahaman? Semua boleh diterima? Siapa rasa semua boleh diterima? Ataupun semua tak boleh diterima sebenarnya? Semua ni tak betul sebab kita tak nampak kan?
The second one, right, sir?
Okay, good. Good try, Arif. Arif cakap the second one is the right definition. Betul? Siapa setuju dengan Arif? So, Arif pilih yang ini.
Saya rasa third, sir.
Siapa tu? Oh,
Saya
Leticia.
rasa third, sir.
Okay, good. Husna dengan Leticia sokong yang ketiga. Yalah, kita tulis nama sikit lah supaya nak tengok sikit sama ada korang ni ada pegangan hidup ke tak ada. So, ini adalah Husna and Rachel. Anyone? Ada lagi? Ini adalah Arif. Yang lain macam mana? Kita nak tahu juga pemikiran korang secara mana kan?
Fatini nombor 2, sir.
Okay, Fatini dan Arif. Kristina, Humairah.
Saya nombor 2 juga, sir.
Kristina, Humairah nombor 2. And then who else? Hazimah Fauzi. Okay, dia nak dengan Husna juga. So ni Hazimah. Arham?
Saya tak suka dia orang, saya nak nombor 1.
Awak tak suka dia orang? Kenapa awak tak suka dia orang? Dia orang baik ke? So Arham nombor 1. Siapa suka Arham? Haziq suka? Nombor 1 ke nombor 2, nombor 3?
Nombor 1 juga.
Awak pun nombor 1 juga? Alia?
Saya nombor 2 sir.
Kita tengok berapa peratus yang betul sebenarnya kan. Okay, Alia and then Dina. Awak nak yang mana?
Nombor 3.
2 dan 3.
Tiga.
Oh, dia salah satu je, Cik Wan.
3 saya 3.
Okay, Cik Wan. Okay, Wafi.
3.
Siapa lagi yang belum?
Saya pilih nombor 1, sir.
Siapa dia tu?
Aziz.
Aziz. Aziz, nombor 1. Okay. And then siapa lagi yang belum? Okay, saya tutup kat sini lah. Yang mana belum tu nanti kita akan bagi dia soalan. Dijawab. Kita reserve for them. Okay. Right, so 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 12 orang memberi jawapan. Kau ada 19 kan? So, ada 7 orang nanti kita akan reserve untuk jawab soalan, right? Okay, jawapan yang sebenarnya adalah nombor 1. Okay. Tahniah kepada Arham, Haziq and Aziz. Jawapan yang sebenarnya adalah nombor 1. This is common mistake yang kebanyakan student around the world buat. Kenapa? Mana mistake dia? Nampak macam nampak macam betul kan, tetapi sebenarnya tapi sebenarnya if you look at the second one minimum energy required, okay, that is definition untuk IE lah ataupun international ionization energy, to remove 1 mole of electron from a gaseous atom. So 1 mole and a gaseous atom. So dia salah sebenarnya. As we know, 1 mole tu ialah 6 times power of 23 kan. So dia salah. If you want to use the 1 mole, it's not a gaseous atom, it's a 1 mole of gaseous atom. So dia kena macam tu. So energy required to remove 1 mole of electron from 1 mole of gaseous atom, then barulah ini betul. Kalau dia just cakap 1 mole of electron from a gaseous atom, so dia akan salah. Tak betul. So we are not remove 1 mole of electron from 1 atom of gas. No. Kita hanya remove 1 electron daripada 1 gaseous atom. So this is a perfect definition lah. To remove 1 electron from 1 gaseous atom and form ion. Ataupun to remove 1 mole of electrons from 1 mole of gaseous atom. Pun diterima juga. Sama juga macam yang ketiga ni. To remove 1 electron from 1 mole of gaseous atom. So, no, this is not the perfect definition. The perfect definition adalah the first one. So, hopefully korang be careful with the terminology. Dan IB sangat-sangatlah panggil sangat-sangatlah particular tentang benda-benda macam tu. And then this is how we write the equation lah for the ionization energy. So this is the first, second, third, so on. Okay, next question. Okay, ada soalan so far pasal first ionization energy? Tak ada? Kalau tak ada, kita tengok sikit lah. Saya share screen kan? Ada nampak screen lagi?
No, sir.
Saya tak share screen dah.
No, sir.
Okay, can you see this? What you call this? Graph.
Nampak, sir?
Just want to show you the very orang panggil sebagai sudden jump of energy. Okay, so atom in the real world we know consists of electron, proton, nucleus semua kan. In the real world, we have the ability, we have power to remove the electron from the atom and make it become ion. So we can do that actually secara physically ataupun chemically. Kan? So secara chemically, we give the electron energy, like kita bagi dia energy lah, heat ke apa ke, so sampai dia ionize. Secara physically, we use the electron gun to bombard. Kan? So just nak tunjuk kat korang lah secara physical dan chemical. So if you have this kind of equation, this is not magnesium, this is M metal, and then this is ion plus electron. Okay, this is ionization energy secara chemistry, secara kimia lah. Chemically, we make this gas become ion. But sometimes we can use the mass spec, so plus electron. So we use electron gun so that we can have. Okay, this is not ionization energy. This is secara physical. So we tembak electron with a higher energy. So dia akan jadi, and the product is still the same. Still gaseous ion. Satu secara chemistry, satu secara physical. Faham? So ada dua cara untuk menjadikan mereka gas. So di mana yang kita tahu, okay, kita ambil contoh yang simple lah. Simple adalah sodium. Sodium ada berapa elektron? Sodium ada 11. So sodium ni penting tak dalam hidup kita?
Yes.
So pentinglah kan, sebab dia adalah komponen utama dalam bentuk garam. So dengan adanya garam, masakan kita akan jadi sedap. Sama juga dengan life kita kan. So ini yang korang belajar masa form 5 dululah. So your chemistry teacher tunjuk. And actually we can, like I said, we can remove the electron from here, and then they can form an A+. Can we, when we remove this electron, so there is no more electron here, betul tak? Padam lah. No more electron in the third shell ataupun third entry level. But I want to manipulate this atom again. I want to remove the next electron, which is in the N2. I want to ask you a question. Sorry, this is N3, this is N1. What do you think when I remove an electron at N3 compared to electron at N2? Yang mana require more energy?
At N2.
N2 lah. The reason is because we know the center of atom tu ada nucleus, so dia akan tarik elektron tu lagi kuat from compared to the N3. So that is why if you see, this is energy, and then this is number of electron removed. When you remove the first electron, is not so much energy required. But when you want to remove the next electron, panggil sebagai successive electron, you will require energy a bit higher. Tetapi dia akan tengoklah macam this is ada sudden jump. Ini secara gradually kan. Ini secara gradually increase, tapi not sudden jump. This is first electron, this is second, this is third, fourth, fifth, and so on. So, why the second electron I required more energy to remove? It is because the second electron location there located at N2. So that is why I have to remove the electron, but give me more energy. So that is why there is a sudden jump. So the sudden jump, ini yang paling penting sekali ni. The sudden jump ni can be used to determine the energy level of atom. Okay, the first, the second, and the third. So bermaksud, okay, this is the first, second, and third. So bermaksud, sodium atom ni ada 3 energy level. So, when you want to remove the second, third, fourth, fifth, 6, 7, 8 tu, there is no sudden jump because the electron location dia at the same energy level. Ada 8 kan. And when you want to remove elektron yang ke this is 8, 9, yang ke 10, there is a sudden jump because the second the 10th electron tu location dia adalah dekat N1. That is why there is a sudden jump. So the sudden jump indicates to us yang the next electron removed is from different energy level, not the same energy level. Right. Ada soalan so far? Tak ada soalan? Okay, very good.
Saya nak tengok yang tadi, sir.
Ya,
Gambar. Sir, kan yang dekat yang peak tu kan? Yang nombor
Dekat yang
9, yang
9
atas
tu?
ni, dekat atas nombor 9 tu, dekat energy level nombor 2.
This is energy level yang this one Yang Y ni?
Yang tu dekat 2 lagi ke?
Yes, dekat 2 lagi. You want to remove the 9th electron. Sebab apa? 1, 2, 3, 4, 5, 6, 7, 8, 9. Kan? So remember your chemistry teacher dulu ajar macam ni kan? Walaupun this is not the correct punya panggil to represent, to explain the atom. Tetapi it's very helpful for us to understand this concept by using this rather than we use 1s2, 2s2, 2p6, 3s1. Boleh juga guna ni, sama je kan. Cumanya ni secara visual, this is secara teori yang sebenar lah kan. So you remove the first electron at the third energy level. When you want to remove the next electron, the location of the electron tu dekat second energy level. So that is why there ada sudden jump. This is N3, this is N2, this is also sudden jump, this is N1. Soalan dia akan tanya kat korang macam ni lah. Looking at this graph, predict this graph belong to what element. So korang kena tahulah. Korang kena kira kan. So kita boleh remove the electron sampai like N11. Tapi energy required is very high. Okay.
Okay, faham, sir.
Faham? Okay, kalau dah faham, I think we stop here because ada lagi 2 minit. So biarlah korang bertenang sekejap sebelum next class. Just want to wish you guys luck untuk topic test kali ni. Try to get a higher mark, nanti kita akan